This is Twitter Think. Welcome to this channel. If you haven't watched the previous videos and this one, open my playlist Engineering Maths 1, search for differentiating an implicit function part 1, 2 and 3. Go over the previous videos. I have done a lot of examples there for you to understand. I am taking the last example and then this topic. For implicit function, there are some basic rules that we should know. The first rule is to differentiate the function. You apply derivative to both sides of the functions, to this side, the right and left side. You use the derivative to multiply the functions like I've written here. So use the derivative to multiply each term one by one. Differentiate each term accordingly. You differentiate the term one by one. You factorize dy dx by grouping all functions containing dy dx to the left hand side of the equation. And then from there you make sure that the equation is equal to 0. So these are the basic rules. As I go through, I will explain. So the first function, we have sine x plus 2 cos y equal to 1. So the rule says that apply derivative at both sides. So I will apply derivative. We are differentiating the whole function with respect to x. So derivative of sine x plus 2 cos y equal to derivative of 1 dx. We are differentiating all the functions with respect to what? X. That's why we have ds there. Now use the derivative to multiply each term. That's what I said in the rule. So I'll use d ds to multiply this, d ds to multiply that. So I have derivative of sine x dx plus derivative of 2 cos y dx, giving me derivative of the constant 1 dx. Now we differentiate each term one by one, and when I differentiate sine, the result is cos. So when I differentiate sine x, I'm getting cos x. So I am differentiating the function sine x with respect to what? X. So it will be d dx times the result that I'll get. So let me write it down, then I will explain. So I have differential of this will give me cos x dx dx. You must remember that the only difference in implicit function is that when you differentiate the function with respect to x, you indicate it. So you differentiated sine with respect to what? X. So sine x with respect to x. So you show that you differentiated x with respect to dx. So you write your dx dx. Dx is actually 1. You can cancel it out, but I want you to understand the concept. That's why I repeated it. Then plus, there's already a constant here. We can bring it outside. So 2. Now let's differentiate cos y. Now when I differentiate cos y, the result is minus sine y. When you differentiate cos, you get minus sine. So minus sine y. Now I differentiated a y term with respect to dx. So I'll indicate that this is dy dx. Then equal to the differential of a constant is 0. So when you differentiate the constant, you get what? 0. So now I can say that this will give me cos x ds will take care of itself. You have into 1 minus 2 sine y dy dx equal to 0. So now this is it. So the result is giving me cos x minus 2 sine y dy dx equal to 0. This is my final answer. Note that there was a step that I wrote here. Now make sure the function is equal to group like terms, factorize dy dx out. Now when we look at this one, there is only one term that contains the dy dx, only this term. So there's no way I can factorize it. And then the term containing the dy dx is negative, so I don't want to write the negative first, so that is why I maintain this one. So that is the solution for this. Now let's take the next example. So this is the next example. The rule says apply derivative to both sides of the function. So I have d, and remember we are differentiating the whole function with respect to x. So d of x squared plus 4y squared minus 4x minus 8y plus 4 equal to derivative of 0 with respect to x. In our next step, use the derivative to multiply each term. So I have d dx of x squared plus d dx of 4y squared minus d dx of 4x minus d dx of 8y plus d dx of 4 equal to dx of 0. Then we now differentiate each term. Now when we look at this, there is no product function. None of the functions are multiplying x. We don't have an x and y term multiplying, so we can just differentiate them one by one. So when I differentiate this, I am getting 2x. I differentiated x with respect to dx, so 2x dx. Once you understand the concept, there is no need to repeat this step. Then plus, when I differentiate this will multiply the 4. I am getting 8y dy dx. I differentiated y with respect to x. Minus, when I differentiate this, I am getting 4 dx dx. The exponent here is 1. 1 times 4 will give me 4. 1 minus 1 will give me, so x raised to the power 0. X raised to the power 0 is 1. 1 times 4 will give me 4. And I differentiated an x term with respect to what? Dx, so dx. Then minus, when I differentiate this, 1 times 8 will give me 8. 1 minus 1 will give me y to power 0, giving me 1. So minus 8 dy dx. And then plus the derivative of a constant is 0, equal to derivative of 0 is also what? 0. So that is what we have. Now we group all terms containing dy dx to one side. The remaining terms will come behind the first one. So let me start with the positive one. I have 8y dy dx. Then I have another term having dy dx here, minus 8 dy dx. Then ds here is 1, so 1 times 2x will give me 2x. Then dx here is 1. 1 times 4 will give me minus 4. 0 is not necessary, equal to what? 0. So now we factorize the dy dx out. So now when I factorize this, I'm getting 8y. When I factorize dy dx, minus 8 into bracket dy dx. There's supposed to be plus here, plus 2x minus 4 equal to 0. So now don't bring the dy dx in front. It should always be at the back. These are the coefficients of the derivative term. So this is our final answer. This is the end of the video. My name is Daniel. If you haven't subscribed to this channel, kindly do. I will see you in my next video.